not a matrix, but like this guy in the video kept saying that it was a matrix, and I'm like, there's no way it's a matrix.
All right,
It was
let's do this. A separable differential equation is one which all x's and dx's can be separated from all the y's and dy's. This is the only method you know how to solve differential equations because you learned it last year in my class or Mr. Griebel's class. A 5-to-3 ratio of those who learned it from me, those who learned it from Mr. Griebel. Okay, now this is not always possible, but when it is possible, we want all the dx's and x's together. On the other side, the y and dy, and then we can integrate both sides. Okay, you kind of remember that? Okay, good. So this should be a relaxing day for you, right?
No, because we're not going to.
Actually, we're not. Today is nothing new. It is very important to show the separation of variables because that step is a point on the AP test, free response question, which you probably will see as a free response question. Whether you write that down or not, I don't really care, but I have to see the separation of variables. Okay, so we're going to do a couple examples. We are also going to look at the direct proportional situation. Okay. So first example, dy dx is x squared over y squared. And I'm showing you multiple solution curves to that differential equation. Okay, there's like what, 1, 2, 3, 4, 5, 6, 7. But we're going to solve the one right here where we have 0, 2. Which I think is this one right here. Okay. So if dy dx is x squared over y squared, how do we separate our variables? Grayson. What? Okay, essentially cross multiply, right? In this particular case. Side note, I really hate that I said that. I had a professor in college. He was my stats professor for my 300 level stats class. He said in this particular case, probably 30 times in one lecture. Like,
Every time or like one time?
Like every time. It was awesome. In this particular case, I also had a physics professor who would say, I know, you will know, the fly on the wall knows, and then would say something that, well, that he thought everyone should know. All right, let's do some integration. Antiderivative of y squared. Jay Carlson.
1/3 y cubed.
Other side, Austin.
1/3 x cubed plus c.
Thank you very much for the plus c. Remember, we only have to put plus c on one side. Technically, yes, it is on both sides, but then when you combine a constant with another constant, it's still a constant. And so let's just save ourselves the hassle. Let's just call it plus c. All right? Huh?
I knew that, that's why I had to say it.
Thank you. All right, so then what's our next step? Okay. I'm going to leave it as C because 3 times a constant is still C. Yes, it is a different C, but it is still a C. Okay. Our general solution would be this. However, I am asking for the particular solution. When I ask for the particular solution, I want you to actually plug in the value. What values are we plugging in? Well, that's kind of lame, isn't it? What's our C value? 2. Now keep in mind, that's this C value. It is not this C value. If you decided to plug in 0, 2 up here where the arrow is,
I mean, right.
yeah.
Nice.
I was thinking up here. I don't know what I was thinking. What? If you plugged in 0 and 2 up here, you would get a different C value, but when you get to this part, it would still look the same. All right? So, y is the cubed root of x cubed plus 8. That is your particular solution. No, you cannot reduce that. Don't try.
One that just be just
Why would it not be, Isaac Warner? Why? Okay, thank you. All right, next one. dy dx equals x squared y.
Just wait.
So write dy dx equals x squared y, and then our initial condition is 0, 1. Sammy, first step to separating variables. What are we going to do?
You divide the y to the other side, and then you use 1 for the dx.
Like this? Okay. Here's our separation of variables. Plus 1 on a free response problem. Antiderivative of 1 over y, Peter. Antiderivative of x squared. We all did that just a moment ago. All right. This is a process we need to be reminded of, right? To solve for y, what do we do? We need to exponentiate both sides, essentially. E to the natural cancels out. We have y equals, this is always going to be positive, so we don't have to worry about the absolute value. E to the 1/3 x cubed plus c would mean times e to the c. And what is e to the c? It is a constant. So we're going to write it as a different constant, but still a constant. We'll get there. We'll get there. All right, so now if we plug in our initial condition of 0, 1, what is C? What's C? Alex, can you see?
Yeah.
should you be wearing glasses? Do you have glasses?
Yeah.
Well, would you like to move up here?
Too bad.
Bring your glasses on Monday, please. Okay. All right. So far, so good? It's a nice Friday lesson, isn't it? I don't know about you, but today's been crazy. Full moon. It was a couple days ago. I think Wednesday. Did you see the moon last night? What?
The waning goodness. Waxing is when it's getting more like June.
Gotcha.
And goodness is when it's bigger.
Okay. Thank
What's
you.
when it's smaller than that?
But did you see it last night? It was like giant, and it's like orange.
Really big.
I didn't get to go outside.
It's one of these mornings.
Monday or
It gives you a smack.
Well, on Monday the sun was, what? Yeah, it looked pink because of all the smoke.
From the forest fires?
Yeah.
I didn't
Was that too much stupid word?
No, the forest fires are north of us. In like,
I heard it was north of
I don't know of any fires in Kansas. That's where my family was from. Canada. There's Canada, Montana, Oregon, California. All of those states have forest fires, but then Canada as well. All right, let's get back on track. That was my fault. Here's our function, dy dx. Write it down. dy dx is 3x squared plus 1 over 2y. Initial condition 1, 4. This is a free response problem. There are 4 parts to this free response problem that we're going to go through. Okay, so find the slope. Nick, to find the slope, what do we do? If I want the slope where x equals 1, what do we do? Okay, so we want dy dx evaluated at, what is it, 1, 4? What's our slope?
3 times 1 plus 1. There it is.
Okay, now, boring, right? Next part. Write an equation of the tangent line to the graph at x equals 1, and then use it to approximate f of 1.2. So tangent line. I'm losing track of who I've called on. Alex, how do we write the tangent line equation?
You do the y minus the y equation, the y minus 4 equals the slope 1/2 times.
Okay, there is our tangent line equation. Okay, it is nice to have it in this form.
Slope intercept.
No.
Point slope.
Thank you. Point. That word was not. In point slope form, because all we have to do is plug in 1.2.
Slope intercept would be better.
No, it would not. Okay, 1.2 minus 1 is times 1/2. So the y coordinate at 1.2 is approximately 4.1. Okay. All right. Now this is where it gets good. What do you think I'm going to ask us to do next? Solve the differential equation.
Show the separation variables.
Okay. So separation of variables. This is like very similar to the first one, right? All we have to do is cross multiply. So we have 2y equals 3x squared plus 1 dx. Don't get too far ahead of me, please. Austin, please give me the antiderivatives.
It should be y squared is equal to x cubed plus x plus 2.
Why am I saying don't go too far ahead of me?
Probably because you're gonna tell us about plus or minus.
Okay.
And it's positive.
For the general, what? Yes, Peter.
Would that be a point?
I was thinking doc for that. Because I hate getting doc for that.
Then don't do it.
Because sometimes, a lot of times on the board, you don't write it, so.
A lot of
At
least once.
times. At least once.
I remember it was on the back board. I just want, so we'll still get doc. We wanna write it.
Everyone makes mistakes.
You want to write it. Please make an effort to write it every time. Okay?
Effort fails.
Now, please keep in mind that I'm talking and writing at the same time. So sometimes there could be a dy that I forget to write down, and then you remind me because you are paying attention, and then we can all have a conversation about because yeah, that is my expectation that the dy is there. Okay? So sometimes mistakes happen for a good reason, right? So we can have conversation.
Talking during the word, that's not a good
Stop talking about me right in front of me. Our our general solution would be y equals plus or minus the square root of x cubed plus x plus c. Please do not forget the plus or minus when we're talking about the general solution. Why? Because we had to square root both sides. We have to account for the positive and negative root. Now, if our initial condition is 1, 4, which one do we choose? Positive, because our y value is positive. So our y value is positive, which means we have a positive square root. What's our c value? Okay. Are we okay on that? Are we okay on this one? Okay. Let's continue. Okay. Don't write all these words down. But what you need to understand is that when the rate of change of a quantity is directly proportional to the quantity itself, the rate of change is directly proportional to the quantity itself.
When you write some of this, the whole
Probably what I underlined. Yes, you know where this is going.
I hate this. But I'm gonna like
This
it.
one break that.
Or you're gonna try to.
You know how it turns into the
I
other.
get rid of it.
It's not even a month of this, so don't worry.
I heard anything else I think about.
It's the same as PERT. You guys called it HECT, SECT. What did you call it?
No.
C makes a S and a K sound.
We weren't laughing at you, we were laughing at our creative minds.
Yeah.
Okay.
We missed
Do you miss that or the person who came up with those for you?
both. I miss Iowa State. Yeah.
I'm just waiting for
Okay, let's solve, well, okay, let's just go through the motions, right? you guys know what's going to happen, right? dy over y equals k dt. When we do the solving, we get natural log of y equals kt plus c. Exponentiate both sides, and we get y equals c e to the kt. Basically, if you see the words, the rate of change of a quantity is directly proportional to the quantity itself in some way, shape, or form, you know that this is happening, therefore this is your equation, right? Yeah.
How does K dt goes to KT?
So our we're integrating with respect to t instead of x, and so k is a constant, and so it goes to k times t.
K is a constant.
Okay. All right. So apparently I had a slide here. Oh, well. All right. So don't write every single thing down, but write down some important information. So bacteria increased from 400 to 1600 in 3 hours. Probably good information to know. Assuming the rate of increase is directly proportional to the population. Find a model, find the bacteria at the end of 6 hours. So I'll give you an opportunity to write down what you want to for your notes, and then we'll go from there. Give me a thumbs up when you have things written down. Don't start on the problem without me, otherwise I don't know when to move on. Nick, was that a thumbs up? Okay. All right. So find an appropriate model. Since we know that the rate of increase is directly proportional to the population, we can use y equals c e to the kt. Now, c, we like to call that the what? It is the constant. It is the initial amount. Okay? Like PERT, right? Okay? So do we have an initial amount?
400.
400. So we at least know that. We also know that 3 hours later, the amount is 1600. So we can use that to help us find K. So we know 1600 equals 400 e to the K times 3. Right? So 4 equals e to the 3K. K equals the natural log of 4. K is what?
0.462.
Give me 3 more.
098.
Why am I asking for 3 more? Okay? You can do one of 2 things. You can store that number in your calculator, like I taught you how to do last year. Or, and a free cover. Or you can round to 3 extra decimal places. That way it will be accurate when you round to 3 decimal places for your final answer. Okay? So then our model y equals 400 e to the 0.46209 K. Okay? And if we wanted to know the number of bacteria at the end of 6 hours, we would plug in 6. I'll let you do that. That should not be K. That should be a T. What'd you get, Alex?
6,399.
Yeah.
I got exactly 600.
Okay.
That's not.
Because you stored the number?
I got 6,422.
That's crazy. If you got the how do we store the number? Besides using on the face.
So there should be a store, the STO button. Okay. Okay. You know what? Okay, yeah, we better go through at least some of this. Okay, write down the half-life is 1590 years, and we start with a mass of 100 milligrams. Issues over there? Conflicting stories there.
Well, I have some trees.
Okay, what is that? You have like a, is this making you nervous?
I was trying to read it.
Okay. Do you need glasses too?
I have contacts.
Okay. Gotta take care of all these eyes out here. I don't like seeing you guys squint.
The wall here has contacts and no glasses. I'm not wearing contacts.
Peter, you don't? And Sammy doesn't. So, wow.
Well, actually, I don't wear contacts. I wear a contact.
It's the same thing. But PERT deals with money.
Yes.
And so, like, principal and it's essentially the same thing. We're just using different.
I'm just curious.
Our constants are just named different. Okay. Okay. Fun fact. Mrs. Holman had glasses when she was 5, and then in middle school, I got to stop wearing them because my eyes got better.
They're still lower.
Oh wait,
But eventually, they'll start going the other way. Like, I can't remember if I was farsighted or nearsighted, but eventually, as I get older, I'll go the other way.
So they started off bad, but they grew to where they're normal, and then just. You know your eyes.
Yeah, they're just gonna go the other way. Happened to my dad too. Weird, right? It happened. All right.
You're not.
Y equals, do we know our initial amount? 100 e to the kt. Now, let's be careful here. Half-life of 1590, so we know the time it takes to get to the half-life. Whether we know the initial amount or not, we can find K. Why? Because we know the half. So we know that the amount divided by the original amount should be half. K value to 6 decimal places.
Negative 4.35.
What? Negative 4 point?
Yeah.
Nope.
It's 2.
Well, it's to the negative 4 or negative 10.
So 0.0,
10 to 50.
Yeah.
0,
0, 0, 4.
did you say to the negative 4?
Oh, no.
1 less 0.
Yeah.
3 zeros.
4, 4,
What's the next number?
What was it?
Since March disapproved.
4, 3, 2.
3, 5.
okay? So y equals 100e to the negative 0.00043 Why is it negative? Because we're decreasing, it's half-life, we're getting smaller, okay? How did I know that 4.4 didn't sound right? Because it should be less than 1, right? I just didn't hear the rest of your number. Okay, all right, I don't really want to do any more with that problem because I'm getting tired of standing up here. Last problem, and I don't feel like we need to, really. Okay, and I know you're getting tired of me standing up here. So this is our last one. Yep. Let's not worry about the slope field. Just write down the differential equation. I feel like you can do slope fields, but this is another free response problem, okay? So first part of it, draw the slope field. Easy 2 points, right?
We would never do that on the ACC. That's one of those that you just have to. I'd take it.
But this is not the ACT. Who's taking the ACT tomorrow?
Nerd.
Good luck!
I'm
Are you done?
9, you're calling us nerds.
Rest up right now.
Well played, Austin. Just so you know, like this is all being recorded.
Yeah.
So we can always come
But
back to
it-
this
that-
conversation.
They were all nerds.
I heard you guys talking about me yesterday.
Yeah.
Yeah,
We did.
Good enough.
we did, well, we said like high take or something like that.
Somebody said sorry, Dick, or something. I don't remember why.
I don't know. Okay, so let's find the solution to this. Separation of variables. Do you agree? Okay. Okay. Nick, antiderivative for the left. What would it be if it was this? Good. That's okay. That's okay. Sammy, antiderivative of the right.
Negative 1/3 x to the negative, right?
Other way.
The other way around.
So this is x to the negative 2. When we antiderive, we add 1 to the power.
Oh, right, okay. So it's just negative 1 over x.
Uh-huh. Plus c. All right. So when we exponentiate both sides, we get y minus 1 equals c e to the negative 1 over x. And then we have to add 1. Now this is where it gets fun, because we have to solve for c. So our initial condition, 2, 0. So our initial condition is 2, 0. Okay, so we're going to subtract 1. How do we solve for c? No, calculators. How do we solve for c? Divide. And what happens when we divide by a negative exponent?
Okay, down to 5.
Becomes positive when you put it up to the denominator, the numerator, excuse me. So we divide over, so we have negative 1 over e to the negative half. Bring it up to make a positive exponent. Now, if c is negative e to the negative 1/2, and that's being multiplied to e to the negative 1 over x, you're not going to leave it like that. That is not nice. You would write y equals e negative e to the negative 1/2 minus 1 over x plus 1. What? Oh, I'm sorry, that is a positive 1/2. That negative I wanted to just put everywhere. Okay? All right. Best part of this problem. Are you ready? Part C of this problem. You'll never see it coming. What kind of problem is part C?
Okay.
No.
You're gonna have to put it in and put in the end of that equation.
The limit.
What?
No.
That's gross.
Yeah. But I was not. The limit. As x approaches infinity of, what did we have? Negative e to the 1/2 minus 1 over x plus 1. This is not as scary as you think it is.
So it's just gonna be negative e to the 1/2.
Yeah, what happens here? Goes to 0. So negative e to the 1/2 plus 1 is your limit. Which means there's an asymptote there. I know.